let's see if we can get our camera set up. No. Cool. Great. Super great. Let's try that again. No. Cool. There we go. All right. Okay, guys. We are continuing in. We only have 2 more topics, which we'll finish this week. And then go directly into interrupts next week. Super exciting. I don't know about that. I don't know how I feel about that. There's something weird on my screen. Anyway, so we're going to kind of finally get to that full equation where it's that y equals mx plus b. And we're going to kind of talk about it and how to analyze it and how to graph it and etc. Okay. So Zhu and John take the tram, it's like a cable car, from the base camp to the mountain summit. So the base camp's right here at 2,080 feet. Now it's very small type, my bad. Okay. After about 6.5 minutes in the tram, John says, cool, we are a mile above sea level. Zhu says, we passed the 1 mile mark a couple of minutes ago. So there's obviously a very serious disagreement between these two. I hope it doesn't tear their friendship apart. Let's find out.
Good morning.
I'm just going to pause it till this is over.
It is a wonderful B-Day Tuesday. So you're going to do your B specials.
Back to the math. Okay, where was I? Zhu and John take the tram, blah, blah, blah. Okay, so, John says that they're just passing sea level now, but Zhu says we passed that, the 1 mile mark a couple of minutes ago. We're going to construct an argument to defend Zhu's statement. So I'm going to set up a table. I think that's probably the easiest way to kind of see this. So, make it a fairly big table because I think we only need like 4 spots in it though. So for our x value right here, I'm going to do time. Yep. Time in minutes. And then for our y value, I'm going to do elevation in feet. Okay, so we know that they started at 2080, so at 0 minutes when they started kind of like, figuring that out. Right, so it's 0 minute when they start counting, basically. It's when they're base camp, right? They're already at 2080. Now, the vertical feet per minute, it's 800 vertical feet per minute for the tram or like the little cable car that takes them up to the top. So the elevation is increasing like 800 feet per minute, right? That's kind of what we're doing right here. So at 1 minute, we take that 2080 and we add 800 to it. We get to 28, and you can't see that, sorry. So 2080 plus 800 gets us to 2880. And then after 2 minutes, we add another 800. Let's see, keep going here. And we add another 800 onto that. Gosh, you still can't see that. So 3680. And then after 3 minutes, we add another 800 onto it to get to 4480. Oh, one thing you guys should know, right? 1 mile is equal to 5,280 feet. Just kind of as background knowledge. And so then we add another 800 onto that. And we get to 5280, right there, okay? So basically after 4 minutes, right, is when they got to 5280, even though John says it was after 6.5 minutes, right? So that is the argument right there to defend Zhu's statement, is that it took them 4 minutes to get to 5280 rather than 6.5 minutes. So what mistake could John have made? Well, I think the easiest way to do this, to get to that kind of 6.5 minutes, is to take that 5280 and divide by the 800. He's basically figuring out how long it took going, just like doing that whole 5280 right there. So just divide that by 800 and we get to 6.6, which is about 6.5, right? So what mistake could John have made? Well, he divided the mile height, and he divided, and it's 5280. Let's do that. 552.80 feet by the speed of 800 feet per minute. Is that right? Feet per minute? Yeah. Feet per minute to get 6.6. So that's kind of how he did that right there. But he didn't account for the fact that they started at 2080 already. So that's why it took less time to get to 5280 than that 6.5 minutes. It only took 4.5. Well, it only took 4 minutes, right? So that was kind of his mistake right there. And so this kind of just shows the difference between a proportional relationship, which John assumed was happening, versus a non-proportional relationship, which you understood that the situation was. Okay, because he had a starting point not at 0, which is what John assumed, but we had a starting point of 2080 already. Because that's their baseline. Okay. What is the equation of a line for a non-proportional relationship? Again, non-proportional just means that you don't start at 0, right? You don't start right here. You start kind of up, or you can start down too. But in this example, we're going to start up. The middle school student council is organizing a dance as $500 to pay for DJ. DJ Dave will charge $200 for a setup fee and the first hour, or $425 for a setup fee in 4 hours. So how can the student council determine whether they can afford to have the DJ play for 5 hours? So basically, Dave charges $200 for setup fee in the first hour. So that is right here. So setup fee is 125. So we know it's an hourly rate of 75. That's a good breakdown right there. Okay. So we know for the first hour and setup fee, it's $200. Boom. Right there. And we know that for a setup fee, it's just 125. So we'll kind of put a point right there because that's about 125 right there. And we also know that he charges $425 for 4 hours. So 4 and then 425 right here. Let's see. It's going to be, 350. Yeah, it's going to be about right there. Kind of the same spot right there. So straight edge right here. Do our line. So we've got our graph right there. So now we got to figure out if they can get to what's going to happen at 5 hours. So it's going to be right here, which is going to be about $450. So yeah, so 5 hours is $450. So yes, they can afford DJ Dave. DJ Dave. Yeah, just graph your line, kind of like predict and like extend it out a little bit, right? So it's about $450 for the student council. Then they have $50 to spend on punch or decorations or whatever. Okay. Actually, let's put this in an equation. All right. So we know that our slope is 75 because it goes up for every 1 hour, it goes up 75, right? So 2 hours will be here, right? So our slope is 75. And our y-intercept is where it starts, which is that setup fee of 125. Okay, 125 right there. Okay, so if we put it into an equation, right, that's y equals mx plus b. We have our m value, we have our b value, so it becomes y equals 75x plus 125. You're starting at 125, and then you're adding 75 per hour, and the x is equal to the number of hours that you are set up for, right? So if we take that 75, we plug in 5, we can actually do this with the equation very easily, right? So we're going to take 5 hours because that's what they kind of want to see if they have room for, right? And this is just to double check our answer. So we'll say 75 times 5, okay, and then plus 125. Oh, did I get my graph off? Yeah, 5. Okay, well, it's $500, so they have enough. Oh, why did they get 450? Is my graph off somehow? Oh, okay, well, it's a good thing I double checked my work. I trust the math over the graph. So 5 hours is $500. So yeah. Okay, write a linear equation in slope-intercept form for the graph shown. The y-intercept of the line, again, is where it crosses the y-axis. So in this case, it is 2. And the slope, let's see, goes from 2 to 5. So that's a difference of 3. 1, 2, 3 boxes. And then over 1, 2, 3, 4. So our rise is 3. Our run is 4. So we plug in the y. Slope is 3/4. Y-intercept is 2. So that's kind of how you get it from a graph, right? Figure out your slope, figure out your y-intercept, and plug it into the equation. Not too crazy, okay? A saltwater solution is cooled to -6 degrees Celsius during an experiment. The mixture is heated so that its temperature rises at a steady rate. Write an equation to represent the temperature y after x minutes. So it's cooled to -6. So boom, that is our 1, 2, 3, 4, 5, 6. So that's our b value. That's our y-intercept. Okay. Then now we got to figure out our slope, right? So those are 2 points right there. So then we'll figure out the rise and the run. So we go up 1, 2, 3, 4, and we go over by 2, right? So our rise is 4, our run is 2, right? So it's going to be 4 over 2, which is 2, okay? So we have our m value, we have our slope, right? It's our slope right there. We have our b value, our y-intercept. So when we plug it into our equation, y equals mx plus b, right? This value for 2 goes in place of the m. This value for -6 goes in place of the b. So when we write it out as our full equation, we get 2x minus 6. It's basically going up at 2 degrees per minute, right? Because that's degrees here on the y-axis, and then time. I should have actually done that at the beginning. Time for your x-axis, which would be that right there. Sorry. Yeah, there you go, guys. So now we're going to kind of reverse everything. We've basically taken graphs and written the equation from the graph, but now we are given our equation, and we're going to write or draw the graph, right? So +3, we know it's going to start at 3, because that's our y-intercept, and we know we're going to go up, down 4, and right 1. So 1, 2, 3, 4, and right there. And you generally want to get as many points as you can, but that'll send us off the graph if I keep going. So 2 points is technically all you need to draw a line. Make sure you draw the line all the way across. Do not just connect there to there, okay? All the way across. And that right there is your, that's it, guys. I'm going to fold this in half, put it in your notebook. Where is my notebook? It's on my desk somewhere. Yes, I'll be right back. Because it's going to go on, for me, page 30. I guess I don't really have any. Oh, well. Page 30. This is 2-9. So analyze linear equations and y equals mx plus b. Okay, and guys, I tend to write it as a capital B because my B's, when I write them out, tend to look like 6s. So just so you know. Okay, now we're going to put it in our table of contents. Be the very last one here, right? So page 30. This is 2-9. Analyze linear equations in the form of y equals mx plus b. Okay.